Hi, I'm Sai, a machine learning engineer at Latent AI. I'm a part of the AI ML team where I work on building and developing LEIP Design. Our toolkit simplifies the entire machine learning workflow into three key processes: design, optimize, and deploy. Compared to traditional ML workflows, which often require complex code changes and deep expertise, LEIP Design makes configuration straightforward. I use LEIP Design to quickly prototype and validate machine learning pipelines, ensuring they're efficient and ready for deployment across different hardware platforms. The best thing about LEIP Design is how it removes the guesswork from optimization and deployment. For example, if I want to accelerate a model on an NVIDIA Jetson, I don't need deep knowledge of TensorRT or CUDA. I just select Jetson as my target hardware and LEIP handles the rest, optimizing the model, integrating necessary libraries, and ensuring smooth performance, all with a simple configuration change. LEIP Design doesn't just save time, it makes advanced ML workflows accessible to everyone.
Let's walk through a hands-on demo of building, optimizing, and deploying an AI model using LEAP Design tailored specifically for your target hardware. In this demo, I'll be using a fire and smoke detection dataset, and I'll guide you step by step as we execute the code together. In step 1, we have to prepare our pantry. This is where LEAP Design organizes essential components like models, datasets, and optimizers. Without LEAP Design, this setup might involve manually gathering dependencies, configuring environments, and resolving compatibility issues across multiple tools. Instead, a single command here ensures that everything is initialized and ready to use. Once the pantry is set up, let's move to the next step. Here, we have to select a recipe. I'm selecting a pre-configured recipe using a unique recipe ID. Recipes in LEAP Design act as modular, reusable templates that handle training and optimization settings. Traditionally, you might have to manage training scripts, hyperparameter configurations, and hardware-specific optimizations separately. LEAP Design eliminates that hassle by combining these into one cohesive workflow. In this step, I load the recipe and show you how flexible it is. You can tweak parameters like learning rate, batch size, and target hardware, such as selecting a Raspberry Pi or a GPU, and you can view them all under these recipe details. Moving to the next step, we need to select a dataset. With the recipe loaded, we are trying to integrate our fire and smoke dataset. Leap Design makes this process seamless by allowing dataset replacement directly within the recipe configuration. Imagine manually preparing data pipelines, validating formats, and aligning pre-processing steps. Leap Design simplifies all this within just a few clicks or a few lines of code. Once we have that, we now need to set up our recipe for training. Here comes the exciting part. Typically, setting up training involves configuring scripts, handling tools, and tuning various parameters, a process that's prone to human error. Leap Design automates most of these by automatically filling in any missing configurations and providing real-time monitoring, as you can see with TensorBoard integration, for instance. Now, let's kick off training. Training took about 15 minutes on this particular recipe on our given hardware. And once training is complete, now we can evaluate the model's performance to verify the mean average position, or MAP. We can also display further detailed evaluation metrics just by using the simple command. Now, once we have this, we can also visualize the predictions from the model just by the simple visualize predictions command. With the simple helper function, we can also display the output from the model. As you can see, the outputs are displayed. Now, we will compile and optimize for our target hardware. In this case, let's just target a CPU device. Optimizing a model for edge devices often require various tools to be mastered, such as TensorRT or ONNX runtime, and manually balancing trade-offs in speed, memory, and accuracy. Leap Design integrates this process into a single step, automating all the complexities for you. With a simple command, we can compile our model. The compilation stage takes about 1 minute to finish executing. Once that stage is done, we can also reevaluate the compiled model in order to ensure that it meets our expectations. Once this is run, we can move to the final stage of our process, which is generating the stub code. Here, we generate the stub code along with the compiled model artifacts. This deployment-ready package will include The optimized model, as you can see, is model library.so with the inference script info.py and the other configuration files. In traditional workflows, creating these deployment packages might require exporting these models, writing custom inference scripts, and manually bundling configurations. Leap Design unifies all these tasks, providing a package that's ready for real-world inference tasks with minimal effort. And there we have it. Using Leap Design, we have selected and configured a recipe, we have integrated a fire and smoke detection dataset, we've trained it and evaluated our model, we've optimized it for edge device deployment, and we've generated a complete deployment package. What would otherwise involve juggling multiple tools and repetitive manual processes is now streamlined into one intuitive platform. Leap Design simplifies AI model workflows, making it easy to go from concept to deployment efficiently. Thank you.